This is Mr. Ward, and this is the Algebra Exit Ticket 35.1 video key for A, B, or 35.2 for D block. And here we go. So we're going to factor y equals x squared minus 4. And this is a difference of squares, which, of course, has a 0x in the middle there that's just not written. So we need two factors of negative 4 that add up to 0, since it's not written in there. So that just ends up being x plus 2 times x minus 2, because 2 and negative 2 multiply for negative 4, and they add up to 0. So they cancel out the middle term. So those are the factors. And what that tells us, of course, is the x-intercepts of this would end up being negative 2, 0, and 2, 0, based on those factors. Okay, the y-intercept, by the way, is just negative 4. Okay. And we're going to calculate b squared minus 4ac for this quadratic. So we know that a here is the x squared coefficient, so a is just 1, because nothing is being multiplied by x squared other than 1. We know that b is negative 7, so I'm going to put that in parentheses and make it a negative 7. When you're squaring a negative number, it's important to put the negative inside parentheses. Otherwise, we think we're getting the negative of the square of positive 7. And that's a different number. C is 3. So A was 1, B was negative 7, and C was 3. So let's calculate all of this. 7 squared, the square of negative 7 is still positive 49, same as the square of 7. And then I'm going to be subtracting 4 times 1, so that's 4, times 3, and 4 times 3 is 12. And so 49 minus 12 is 37. Okay, now that you've simplified that part inside the square root, try to find the solution for all of this using the quadratic formula. Okay, so you could do this on Desmos if you have access to that right now, and so that's just what I'm going to do, but you could do this on paper as well. So I'm going to copy this equation. So I have the notes there. I'm going to go to Desmos, and I'm going to put this in a note so I don't accidentally graph it in front of you. And here we go. I'm going to put it in parentheses so that I can keep that in a numerator. Negative b plus or minus the square root sqrt of b squared minus 4ac, and then all over 2a, and now I can drop the parentheses because they're no longer needed because the fraction bar does the job for us. Okay, I'm going to deal with the minus version in a second. We know that a is 1. We know that b is negative 7. So wherever it shows up, we'll put in a negative 7. I left out this a, so this a is, of course, 1. And the c is 3. Now, we already worked out that this stuff up here is 49 minus 12. So 49 minus 12, which will be 37. And 37 is a prime number. We're not getting a neat and tidy square root out of that. We can clean up 2 times 1 as 2. We can clean up negative 7 as just positive 7. And now we just need the negative version of this as well. And there you have exact answers, 7 plus or minus the square root of 37 over 2. And if you wanted estimated rounded answers, you could take one of these two decimals, and you ended up with 6.54 and 0.46 if you wanted. And those would, of course, have to be rounded because they go on forever, because they involve the square root of 37 somehow in there. And that's going to go on forever and have no end and no repeating pattern that lasts for any particular length of time. So these are irrational numbers. These are irrational numbers. You have to round them. So any efforts to use decimals to get accuracy actually yields false accuracy. These are the most accurate answers. These are the exact answers. So 7 plus or minus square root of 37 over 2. Okay, so let's put that in here. So I'm going to put in parentheses 7 plus or minus, and then I'm going to type in SQRT 37, and that's going to be all over 2. And that is the two solutions, 7 plus and 7 minus, the square root of 37, all over 2. Okay, so which one of these would be the simplified version of the square root of 37? Well, it's just plus or minus square root of 37 because that's all you can do with a square root of 37. It contains no factors that are neat and tidy squares. So you're done with that one. And I hope that